Hey guys, sorry about rushing so much at the end of my last video. That's just because if you actually look at how much time there is, since YouTube has a 15-minute time limit, I had 2 seconds left. So by the time I ended, there was actually 2 seconds left. And if I go over, I wouldn't be able to upload it. So I guess I'll just quickly cover this again. It is to solve this question, you just multiply the inverse by the matrix that they gave you. And if you look at this, the multiplication of this is just, since these are zeros, you're just going to be multiplying -1 by the inside of the middle row, because this times this is just 2 times 0 plus -1 times -1 plus 3 times 0. That's just 1. And it's going to keep doing that. And because these both are zeros, you're just going to be taking the middle row here and multiplying it by -1 to get this row. So now we're on to question number 4. Now this question seems to have had a bit of a, what you call it, disagreement about it. So I'm just going to go over this a little bit more carefully than usual. So it wants us to, for A, it wants us to figure out the matrix which would rotate at 60 degrees clockwise, but it would first reflect the vector about the line y equals -x, which is at angle. If you think about -x and where it lies, it's just going to be 90 plus 45. It's 135. And then it wants us to reflect it clockwise by 60 degrees. But since the rotational matrix that we're given is counterclockwise, this is the same as rotating counterclockwise by 300 degrees. There we go. So now we're just going to multiply the reflection matrix by the rotational matrix using these angles. So the reflection matrix has 2 theta in every single thing. So we're going to take this value here and we're going to double it. So it's going to be cos 270. It's going to sine 270. It's going to be sine 270. Negative cos 270. This is going to be times. I'm going to use 300 degrees. So I'm trying to do this a bit fast here because last time I ran out of time. And use sine 300 minus sine 300 and cos 300. There we go. Now I'm just going to quickly pull out a detail where my actual derivation of this, because apparently there's disagreement. So this I got to be equivalent to cos of 270, since it's on the y-axis, is just 0. So these are both going to be zeros. And sine of 270 is -1. The cos of 300 is a half. Sine of 300 is -√3/2. So negative sine of 300 is just going to be √3/2. This, when you do it, it's going to be this. It's going to be this dot product of this, which is going to be √3/2 over here. And with the dot product of that, which is -1/2. Then this row dot product with this row, which is going to be -1/2. This row dot product with this row, which is -√3/2. And that's your answer. Now on the Facebook group, they pulled out the -1/2. I'm not going to do that because in the next part of this question, we actually have to use this exact matrix. We can't use the -1/2 out because that changes the values in the matrix. So remember, when you're finding the inverse of a matrix, don't pull stuff out. Take the original matrix with all its horrible, nasty fractions and work with them. I'm just going to take this away and replace it by another piece of paper quickly. And there we go. So B says find the inverse of that. So again, I'm going to write out the matrix. -1/2, -1/2, negative root 3 over 2. Now I'm gonna add the identity matrix here. And now all you gotta do is take that to reduce row echelon form in order to do what we need to do. So let's just do our steps. 1, and there's 0 here. So how do we get the top row to 1? And we divide everything by root 3 over 2. Now if we divide negative half by root 3 over 2, we're going to multiply by the reciprocal. The 2's are going to cancel. And we're going to be left with negative 1 over root 3. And rationalizing that gives us negative root 3 over 3. Now you wanna practice on being able to do fractions like that quickly, at least that quickly in your head, because it's gonna be useful during tests or midterms or whatever to be able to do fractions like that. Now 1 over root 3 over 2 is just 2 over root 3, and rationalizing that gives you 2 root 3 over 3. And that's because when you take the bottom and you multiply it, you take that 2 over root 3 and multiply it by root 3 over root 3, you get 2 root 3 on the top, and root 3 squared is just 3 on the bottom. And 0 over any number is just 0. So next, we got to figure out how we're going to get this row here, that number there, to 1 using either of the top rows. So I'm obviously going to use the first row there. This row here, I'm going to take half of it and I'm going to add it to this row. So I'm going to take half of root 3 over 3, I'm going to add it to root 3 over 2, to negative root 3 over 2. So this is just going to be negative root 3 over 2 minus root 3 over 3. If you factor out the negative root 3, you get a half plus a third, which is, wait, that's not right. No, that's not right. That negative plays with it a little bit. I'm just going to show you guys the fractional work up here. Yeah, I guess this is kind of... See, there's that, it's the minus 6 there. That's why the half messes around with it a little bit. So you factor out the negative, and you end up getting a half plus a sixth, which is... 3 over 4. So you're going to multiply this by 3. So you end up going to get 3 plus 1, which is 4 over 6. Negative 4 over 6, which is negative 2 root 3 over 3. We're going to do the same here. We're going to take half of this and add it to 0, which is just root 3 over 3. You gotta be thankful for the ones that are easy. And this is just 1. So, again, gotta be thankful for the ones that are easy. So next we're just gonna finish this up. Like that. And we're gonna see how we get this to 1. Divide this by itself. So we're gonna divide this by negative 2 over 3 root 3. The 3 over root 3's are going to cancel, and we're going to be left with negative half. This is going to be negative 3 over 2 root 3. Rationalizing that gives you, let me think about it. You're going to multiply the bottom by root 3. You're going to be left with 2 times 3 on the bottom. And the top's going to be 3 root 3, and the 3's are going to cancel, and you'll be left with negative 3 over 2. Now all we gotta do is think about how to take the half. Or we gotta take how to take this to 0. Using what? So we're gonna take this, and half of it, and we're gonna subtract it from this one. I know that might be a bit weird, confusing, tricky, but that's okay. Because we take half of it, we're gonna get rid of the 2's, and we're gonna be left with negative root 3, and a negative root 3 to get rid of it. So if we just subtract negative root 3 from negative root 3, we get 0. So we're gonna do the same thing. We're gonna take the 2 here, so we're going to take half of it and we're going to subtract it from this. So that's just going to be 2 root 3 over 3 minus root 3 over 6. So multiply this 2 by, so I'm going to take this and I'm going to multiply by 2 over 2, 4, 6. what we're left with is 4 root 3 over 6, which is, sorry, 3 root 3 over 6, which is half root 3. So this is root 3 over 2. And you can see why taking half of 1 and subtracting it from 0 gives you negative half. So the inverse here, it's just root 3 over 2, negative 1 over 2, negative 1 over 2, negative root 3 over 2. There we go. If you don't trust my algebra or you want to go through it quickly again yourself, then by all means try to do the matrix row reduction yourself. It's not too bad. As you can see, you can do it in 3 steps, but it's okay. So next, C asks us if the transformation defined as A is further followed by a projection onto the y-axis, would the resulting transformation be invertible? Now, the answer here is no. And that's because if you take it, sorry, what am I saying? If you take the, because the inverse is equal to the original itself, there are 2 ways of getting to the, there are 2 ways of getting to one point. So that means you have 2 input values for one production, which you can have. But just in case, it's a bit confusing if you explain like that, so I'm just going to show you the obvious way of taking the determinant. So, root 3 over 2, negative half, negative half, negative 3 over 2. So this is going to be times the rotational matrix. So it's going to be times the projection matrix, which is half. We do that, and we're going to use 90 degrees as our angle. This is 1 plus cos 2 theta. So all these are just 2 times 90, if you're wondering where the 180 comes from. Oh, 180. Now calculating the determinant for this is ridiculously easy because we know the sine of 180 is 0. We know cos of 180 is negative 1, so 1 minus 1 is 0. So the resulting matrix, doesn't matter whatever happens, it's going to be a dot product of this row here. And we get 0 plus 0, which is just 0. And actually, we don't even care about the rest of the entries. Because since the determinant is a product of the diagonals, it doesn't matter what the bottom right number is, determinant is going to be 0. So, not invertible. And that is how you do question 4.